Good day once again. You are welcome to another section of Physics 191, and today we'll be considering moment of inertia, experiments related to moment of inertia. If you have a cylinder of mass m, then dynamical theory shows that provided no slipping occurs, the acceleration of the cylinder down the plane is given by the expression you have in equation 1. That is, A equals GH divided by L into 1 plus I, that's capital I, over mr square. Actually, that capital I is the moment of inertia that you want to obtain. H is the height of the inclined plane where you place your cylindrical object to roll down, to slide down. R is the radius of that cylindrical object. And of course, L is the distance of fall of the cylinder on the inclined plane. Furthermore, from your equation of motion, or which I can call the kinematics equation, one of the equations says that S equals to ut plus half at square. S is the distance covered, A is the acceleration, T is the time. And from that, you can say that if your initial velocity is 0, because the cylindrical object is at rest, then L is representing your S now, as you can see in that equation 2. So if initial velocity u is 0, the equation will be reduced to L equals half at square, where T is the time taken for the cylinder to roll down the plane. And now if you put equation 1 and 2 together, then you can obtain what we have in equation 3, which is the height h, and you have it as it is shown in equation 3. Then this shows that a graph of t raised to power minus 2, that is inverse of t square, against h, we have a slope of what you have in equation 4. So if you successfully plot a graph of inverse of square of the period against the height h, then definitely you can have your slope to be equal to what we have in equation 4. And the essence of this is, once you have the slope obtained, you can make I, which is the moment of inertia, the subject of the formula. And once you make it the subject of the formula, definitely you have been able to achieve the moment of inertia you want to obtain. So all you need to do in this experiment is vary your h, the height of the inclined plane, vary the distance of the fall of the cylindrical object, time it with your stopwatch. Then for each of the height, for each of the lengths, you determine your t, and with a suitable graph and with your slope, you obtain your moment of inertia. And you can see equation 5, I equals to half mr square. And the procedure, I've explained it, I'm just showing it again. And in summary, you have learned how to set up the moment of inertia experiment. You have also learned how to measure the time t for several different values of height of the inclined plane, like I said earlier. You have also learned how to plot a graph of the inverse of square of the time against h and estimate its slope. Then finally, you have learned how to determine the value of the moment of inertia I, given also the error in I. This is the end of this session on moment of inertia related experiments. Thank you.